So what this webinar is about is giving you some tips and tricks on what the correct hardware infrastructure is to make sure that you're running as quickly as you can and as reliably as you can. So fast and reliable, they're the two key words here today. So with that, I'll hand over to Bob, and Bob will take it to us. Actually, just before I do that, I will also encourage you, so the webinar is very comprehensive. It will be recorded, you'll get it, but I'd also encourage you to, to contact us directly. We're more than happy to do a web meeting with you and look at the infrastructure that you have and help you to make sure that it's optimized. Okay, thanks, Bob.
Thanks, Derek. As Derek said, I'm Bob Moore, IT Manager with CADFEM UK and Ireland. So just as an introduction, a more technical introduction, we had 3 goals with this webinar. So there's a lot of information out there about HFSS, but it can be difficult to find and piece together. So we put this webinar together, as Derek already said, to help people to get the most out of their HFSS investment. And this presentation is targeted at HFSS, as that tends to be the most resource-intensive electronics product, but most of it is equally applicable to the electronics product family. And also, we're going to present a lot of material here in a short time. Don't worry if you can't follow it all, because the hope would be that you'll get a video afterwards, which you can use as a reference. And there's a couple of handouts as well. And as Derek said, we're always here that you can contact us directly. So with that, I'll hand over to Alex, and he's going to talk about installation. Thanks, Alex.
Thanks, Rob. Hi, I'm Alex. I'm the HFSS guy in CADFEM. Okay, the very first step to start HFSS is to install it. It could be a tricky thing, so I'm just telling you the most efficient way to do it. First, start by removing the previous version. Having multiple versions can cause you issues. I mean, for example, with RSM, which we'll explain later, or space claim. So the best is to have a very clean starting point, remove all the previous versions, then install the very latest version. The latest means R1 in January. So every year we have an R1 in January and R2 in July. That's usually not all. So between R1 and R2, we will have a patch or an update. So that's what you see there in the Ansys customer portal. That gray box is always an update. So what's highlighted in red is the main release. So either R1 and R2, and in between you will have a gray update. And usually this gray update is related to IT issues, so it's stability and make it faster. Also, it's highly recommended to install the offline documentation. So Bob, the next slide, please. Just like the online documentation is a bit slow. Sometimes it can time out. So the most efficient way is to install the offline documentation. Also in the Ansys customer portal, you will see product documentation, and then go to electronics. It just once, but then you'll be really happy and grateful that you've done it. And then you have access to all the offline materials, the offline documentation materials. Also, if you're doing loads of CAD, next slide, please. There are 2 very important tools to install. One is the electronics MCAD translator. That's to import CATIA and SolidWorks. I mean, CATIA and SolidWorks are very common CAD tools, and usually you have your antenna on some platform. This platform usually comes from CATIA or SolidWorks. So you please install that extra add-on. Otherwise, you can't import external CAD. And then Space Claim is also a very nice tool, because it can import and export any CAD format, and it can also do loads of cleaning for your CAD. You know, some CAD have like this so-called sliver faces, which are very tiny, narrow, high aspect ratio faces. They cause issues in the simulation. So with Space Claim, you can efficiently remove all these issues. So if you install the latest version, latest updates, proper write-on, and the documentation, yeah, it's a very good starting point. What's left is license. So next slide, please, Bob. Then you need to install the license manager. And the license manager is a piece of software where you can install your license. We have two versions. So Ansys License Manager without anything means that's the Windows version. Ansys Enterprise License Manager means that's the Linux version. Yeah. So it depends where you want to install that license manager. It's highly recommended to have the latest version. You can be like one or two versions back, but that's not really recommended. And another trick is for best stability, and I'll explain why, is to install the license manager on a separate machine. Some customers we've seen they install the license manager on the same machine which has HFSS, but this is not really a good idea. Next slide, please. So the license manager doesn't need any fancy computer. You see, you can have like any computer, then let's say we're speaking here of like, you know, $200 or $300 or euros or pounds. It just needs a standard Intel chipset or even AMD. We just need 2 CPU cores, and they could be Athlon or Celeron. So that's really the cheapest. And RAM and under 100 concurrent users, which I think that most case, I mean, very few companies will have more than 100 simultaneous users. You need just 4 GB of RAM and basic graphics. But the idea is if you install the license manager and on the same machine that's running solving HFSS, then if it's really crunching numbers and using all the resources for the solving, then it might have not enough resources for the license manager. And if there is no enough resources for the license manager, then HFSS will think, oh, I don't have a license. So the simulation would stop. So despite having a fancy machine and fancy software, the simulation will stop just because it lost the connection to the license manager. So the best strategy is you have a computer for the solving and then a computer for the license manager. And as I said, this license manager could be any old computer you have lying around. Just it needs to be connected 24/7 to your LAN, and that would really give you peace of mind. Next slide, please. As for the license, also we changed the license model 3 years ago. We have the so-called PPE license, which stands for Pro Premium Enterprise. You can think of that as small, medium, large. So Pro is the smallest license. That's for 2D simulations, and I personally don't recommend it. I mean, nowadays things are more complicated. There's some effects which you can't see only in 3D. So I wouldn't recommend Pro. Then you can have Premium, which is enough for all your 3D license, for your 3D simulations. Premium is a very competitive price. And the good news is it's actually 2 licenses. It's 1 solver and 1 GUI. That's very cost effective because that means one engineer could be using the GUI to do pre or post processing, so looking at results or building some model, and the other engineer could be solving. So in fact, these are 2 GUIs included together. Then we have Enterprise, which is the largest. That gives you more than Premium 2 main features. One is Space Claim. As I said, Space Claim is a very good tool to import CAD, export CAD, do cleaning, any transformations, and also gives you a thermal solver, IcePack. So for applications, for example, like high power filters where you get heating, or you have jammers where they emit loads of energy, or for example, phased arrays where you have loads of antennas close together, so the heat density is very high. IcePack is a very good tool, and in the latest version 2022 R2, it just creates the model automatically for you. So that's very high value add-on, and the difference in premium and price is also not that high. So I'd recommend Premium or Enterprise. Next slide, please, Bob. Another issue what people have is the so-called password caching. Many, or I'd say even every engineer would do a parametric sweep. That's the whole point of simulation. What happens if I change this length by that much, or what happens if I change that variable? And a common issue is the so-called password caching. This is something you need to do before you do parametric sweeps. and unfortunately is not really well documented, and many people come to us and say, okay, they have this. So if you see this error message, yeah, it says any attempt solvers failed connecting to communication pipes, MPI, password, any of these error message, that's a hint that you didn't do a password caching. Your safest bet is to do password caching just before you start. It's just one step, and every time you change your Windows password, you need to repeat that. Bob will show you how to do it, and I think then you'll have no problems then with parametric sweep. And to you, Bob.
Yeah, so I'm just going to launch a short video here on password caching. Hi, this is a video showing you how to cache your password for Ansys Electronics desktop. So the first thing we need to do is we need to find where the executable is located for caching the desktop. So if we open up our File Explorer, as you can see, I've already browsed to the correct location. So if we go Ansys EM, '64, common, fluent MPI, multi-port, MPI, Win64, Intel, bin. And it's this executable we need to use. So you can see, depending on the version of Ansys EM, you'll have to cache your password for each one. So here's for 22.2. So let's now copy this, and then if we type CMD into the command prompt, and then we paste, and first of all we need to put quotes around this, MPIEXEC. You don't need the .exe, you can, it's options then, minus register. And then you see it picks up the default account on your machine, which is fine in most cases, but you can change it by just typing a different account. And then you put in your password. And that's it, that's done. So basically, if you're using a parametric sweep, you need to do this on the machine you're using, or otherwise, if you're using more than one machine in a cluster, or then you need to do it on all the machines. Okay, so I'm just going to hand over to Alex now again, just to introduce the HFSS configuration.
Yes, so welcome back. I hope you found this password caching useful. As I said, it's very important, so not to have any issues with parametric sweeps. Now for the HFSS configuration, we have three main configurations. We call them A, B, C. This is just our terminology. A is one of the most common, I would say. Unfortunately, it's not recommended at all, and explain why. Is that you do your pre and post, so you build your models and solve on the same machine. This is not a good idea. Yeah, again, repeat, this is not a good idea, because if you're solving, then you're using all your machine's resources, and then if you're doing the pre and post on the same machine, then it will be hanging. It will not be responsive. Your experience will be suboptimal, and ultimately you'll come to us and complain. So ideally, you should separate that into two machines, and you don't need an extra license for that. Setting it up takes only 10 minutes. It needs to be done once. So I'm just wondering why it's not very common. So I'd recommend either configuration B or C. Configuration B is that you would separate your task into two computers. You'll have one computer for the pre and post, and we call that client. And that doesn't need to be an expensive computer. It could be even a laptop. I mean, that's so you're not wasting the resources of your expensive machine. And then you have a more expensive machine. You have a server where you solve on that. So while that's solving, that's only busy with solving. You're not wasting its time with pre and post. And in the same time, you can do pre and post on your clients, and that's not overwhelmed or hanging because it's doing a solving. So highly recommend that. It's called RSM Remote Simulation Manager. Only limitation is it can't be used only with one user. So you would have to arrange internally. So you'd say user 1 will use it Monday, Tuesday, and user 2 will use it Wednesday, Thursday, for example. Because if you have 2 clients connecting to the same server and sending jobs in the same time, it will just crash if you're using RSM. To avoid that or to mitigate that, you can have configuration C, where you would have 2 users, you would have the solver. So also configuration C does not need any extra licenses, just it needs the configuration. And it's not as easy at RSM. You would need probably Bob's help. I mean, if your IT can do it, then be our guest, go ahead. If not, then Bob can help you with that. Here, the only difference is between B and C is that C would install something called scheduler. And scheduler is just like a conductor in an orchestra, for example. It will coordinate. So if user 1 sends a job, it will put it in a queue. If user 2 at the same time, will just put it in the same queue. So you'll have a queue of jobs and it will be done either one at a time. You can change priority. You can divide the resources so that both of them are done in the same time. You have a log who simulated what model at what time, using what resources. Sometimes if you get, okay, where did I save that simulation? When did I do it? You can go back to the scheduler and you will see a log of every simulation done in the company. Where is it stored? How much time it took and how much resources. And I said it can be used for multiple resources, multiple users, sorry, and could be used on Windows and Linux. We would recommend Windows, but it still could be used on Linux. I'll hand over to Bob. He'll explain the details of every one and what are the minimum and recommended recommendations.
Thanks, Alex. Okay, so as Alex said, well, variant A, which is basically a single machine, the minimum requirements would be 16 gig of RAM and integrated graphics if you're not using any GPU solvers, 512 gig of storage, and Windows 10. Important to note that an Intel 64-bit processor, preferably a Xeon, Intel Xeon processor, and AMD is not recommended. I believe in 2022 R2 there is beta support for AMD, but we'd still advise you to avoid AMD for now at least. And then the recommended would be Intel 64 with 8 to 12 cores, and obviously you can always go higher if you want, and probably you should for HFSS. But this would be the kind of the minimum recommended, I suppose. And 64 gig of RAM, make sure it's DDR4 2933 or better. For graphics, you could use NVIDIA Quadro P4000 or Quadro RTX 4000 with 8 gig of RAM. Storage, 1 terabyte NVMe SSD, which is important for speed, because if you have a really powerful processor and graphics card and your storage is slow, it's going to slow down everything. It's completely pointless. So the faster the SSD you can get, the better. And I'd advise having a separate standard SSD for the operating system, just to take the pressure off. While the job is running, then you have the drive with the OS on it is not being taxed either. And then the OS will be Windows 10, 11, or Windows Server 2019. This is assuming pre-post and solving is on the same machine and up to 400,000 tetrahedrals. And very important, turn off hyperthreading. We can't emphasize this enough. On some of the other technologies, it will run a little bit slower, but with HFSS, it's essential to turn off hyperthreading. So, and then for variant B, where you have the RSM installation, where you can run jobs in sequence. First note, if any of your users of mechanical or CFX, the RSM for HFSS and electronics desktop is completely different. It's nothing to do. They're completely nothing to do with each other, which is a little bit confusing. But just so you're aware, both computers need to be connected to the license server. The password needs to be cached on both machines if you have one server, if you're doing a parametric sweep. Well, in this case, you would need to cache on both machines for RSM. Which I showed earlier in the video. Port 32958 needs to be open. This is assuming you use the default settings, which most people probably will. And then I've got a video to show you how to configure RSM. So let me play that now. Here we're going to show you how to use RSM with Ansys Electronics Desktop. So the first thing we have to do is we need to register on the server. We need to register RSM. I'm just going to use the same machine in this demo, but bear in mind that in reality you use a server and a client. So we just browse to the relevant version of Ansys EM Suite and we scroll down, and then we just right click on this, which is very important, and run as administrator. This process can take from 30 to 45 seconds. I've intentionally shortened it here just for clarity. Okay, so now we have our RSM registered. So the next step is then to open up our electronics desktop. Okay, so then we click Add Machine, and then we can use either the IP address or the DNS name. In this case, I'm going to use the IP address. Add the machine to list, then we select the number of cores we have, and then the number of GPUs, which you don't have any for this machine, and then we just hit test, and as you can see, all the tests should pass successfully. We also need to set a name for this configuration. Then, in order to run the job using this configuration, we can see here that the active one is currently local, so we need to change this to make the remote RSM active. So we click OK, and now you can see here it says remote RSM. So then if we just validate, you can see that it validates with a few warnings, so that's fine. And then we just run analyze all. And as you can see, the job has started to run. So that concludes my demonstration. Let me go back to the presentation. Okay, so then variant B and C, where you've got either a single head node with a scheduler on it, or a cluster with a scheduler. So basically, that's the only difference really between variant B and C. So the minimum requirements for the client would be as you see below, which is similar actually to the variant B as well. Yeah, it's similar to variant B. Yeah, and then the minimum server we would recommend would be an Intel Xeon 64 with 12 cores, 256 gig of DDR4 RAM per million tetrahedrals, and then again the similar graphics cards to what we recommended in the RSM setup, and 1 terabyte SSD and Windows 10. And then the recommended client is the Intel Xeon 64 8 to 12 cores, 64 gig DDR4 RAM, and again similar graphics cards, 8 gig of RAM, and then the separate SSD for the operating system, which is very useful to have, and the 1 terabyte NVMe SSD, which would be faster. And then for the server, Intel Xeon 64 20 plus cores, 256 gig of fast RAM, NVIDIA Tesla A100 if you're using the SBR solver. Now these are relatively expensive, but they're coming down in price all the time, so keep an eye out for these Tesla cards, because if you want to use SBR. And yeah, 256 gig of storage and 1 terabyte SSD for caching, you know, for the actual solving. And Windows Server 2019. As Alex referred to before, if you're starting from scratch, we would recommend Windows and Windows HPC. If you've already got a Linux set up with a cluster and so on, and probably something like PBS Pro or Slurm or so on it, you can add it to that instead. Or unless you obviously have somebody in-house who's big into Linux and can set it up. Otherwise, we'd recommend Windows. And again, turn off hyper-threading on the server. We can't reinforce that one enough. Okay, so then the actual physical configuration of variant C. So if you have a head node, if you want to connect more than, you know, when you've got 2 or more machines. So there's a difference if you've got 2 machines and if you've got 3 or more. So this side here is if you've got 2 machines. So basically what you need then is an InfiniBand cable and two InfiniBand cards, and you can connect them together that way. If you've got more than 2, then you need an InfiniBand switch, which will add quite a bit more cost to the setup as well, because the InfiniBand switches are not cheap, whereas the cards are relatively cheap. So you need to have the switch and 3 InfiniBand cards in the case of having 3 machines. And yeah, this is about the networking requirements. So this is what an InfiniBand switch looks like, and this is what an InfiniBand cable looks like, and that's your InfiniBand card. So it looks a lot like a network card, but it's a lot faster. So for 2 server nodes, 200 gig InfiniBand cards and a 2-port network card. And recommended, again, this is down to budget really, but you're going to, obviously the faster the better. And then if you've got 3 server nodes, you need a Mellanox InfiniBand managed switch as well, and the 100 gig cards, and recommended 200 gig cards. So then for the software requirements, well, on the right is Windows HPC, a kind of an example screen. So you can see here there's lots of jobs that have run and so on, and you know it's very clear. Then you can track who run what job, and you can have queues. You can have priority queues and queues that will, you know, not lower priority, or you can have queues that only run certain times and all this kind of stuff. So it's very very powerful compared to just submitting jobs in series when you have to talk to your colleague as to when you can get the machine and that kind of stuff. So for Windows, it's Windows HPC Pack 2019, which is free, and I've put a link into the presentation, which is in the handout where you can download it. And then you have Windows Server. You need the important thing about the Windows HPC Pack is you need Windows Server. It doesn't run on Windows 10 or Windows 11. That's the only gotcha really with it. So if you're buying a new server, if you're buying a new machine to do HFSS jobs, just buy a Windows Server machine rather than Windows 10 or Windows 11. And then with Linux, there's Altair PBS, IBM Spectrum LSF, Slurm, or Univa Grid Engine. Now, many of you may have one of these already as well, so you can definitely use those. And these are the recommended operating systems for Linux. I won't dwell too much on that. And again, turn off hyper-threading on the nodes. Okay, so these are just ongoing hardware and system maintenance best practices. You're probably familiar with them anyway, but I'll just quickly go through them. Keep the servers in air-conditioned server room. Power management plan to high performance. Don't use RAID or other processes which slow down hardware performance, because that's a mistake some people make. They set up a RAID server to run simulations, which is, RAID is copying data between drives all the time, so it's going to drastically reduce your performance. Only use the servers for solving. Don't be running other software on it at the same time. Isolate them from the rest of the network and the internet, so as to give the maximum network bandwidth to this for simulation. and only allow trusted IT staff to access directly. And all other access should be through a scheduler and not through remote desktop, because a lot of people use remote desktop as well, and that's just, you're using lots of extra resources just to run remote desktop, and you know, it's not best practice at all, really. And install the latest NVIDIA drivers at regular intervals. Have a benchmark to check your hardware. So this is a good tip, that if, say, there's a driver or something, or a network card that's going bad and it's slowing everything down, you can run your benchmark project to get, you know, hard numbers on it, so you can see, well, this ran in 2 hours a month ago and now it's taking 10 hours, so there's obviously something wrong here. Run your Windows update once a month, and then firmware updates once every 6 months. And I've just put some links into Dell and HP there as well for firmware. Yeah, so I'm just going to pass you back to Alex again to talk about the recommended general options for HFSS.
Thanks, Bob. That was very useful. I hope people will benefit from that. So back to HFSS. So let's say you have now the fundamentals, right? You have the IT and software, operating system, everything, right? If you go to HFSS tools, options, general options, there is loads of options that you can set. Most of the default values were set in early 90s with the mind that it should run on the lowest common computer. But nowadays, obviously, computers got better, so you can change the default values to have better comfort, so have better graphics, you have better responsiveness, you have better performance. I said there are loads of options that we can't get through here. Otherwise, we'd be spending hours, and I think that would be too boring. That's why we've put that in a PDF handout. And these settings or these general options are strongly recommended. So you have to do that once. So just, you've done everything. Now we're starting HFSS for the first time. Go to tools, options, change these settings to what you have in the PDF handout, and then forget about it. As I said, it may need more computing, but it will give you more comfortable and ease of use and better experience. Back to you, Bob.
Thanks, Alex. Okay, so you've looked at hardware and you're not sure what you want, or maybe you have some hardware, but you get in now and again a big project that you need to solve and you don't have the resources in-house, and you don't want to leave a big expensive cluster sitting there 6 months of the year doing nothing. Then we also provide a cloud solution. And it's based on Amazon Web Services. So what we've done is we've developed a self-service portal so that people can log in and run their own HFSS jobs, or indeed any of the physics jobs to do with Ansys. And the advantages of this are, if you want to set up AWS yourself or any cloud simulation platform, there's quite a lot of IT knowledge and investment needed to get up and running. So the portal takes that away. Our customers get the full suite of Ansys software they can use immediately. So we keep an image of each new release of Ansys and HFSS available, so that as soon as they come out, we deploy the new image, so it's ready to go. And also a license server that runs in the cloud, so you can also access that license server offline. The network is pre-configured to the Optimum in the cloud. There's also a tailored section to HFSS, so you can launch machines that are already tailored to run HFSS. You can get up and running really quickly. There's overview of ongoing costs, easy management of machines by users. So each user gets an account and they can log in and run a machine themselves, or people can share machines or whatever they want to do. So it's very flexible. And the license server is managed by us as well. So anytime there's a new license, you just send it to us and we'll install it. You don't have to worry about doing any of that stuff yourself either. So it's a good service. And you also have immediate access to the latest CPU and GPU hardware, because AWS are always bringing, they're making the new GPUs available all the time. So if you buy something in house, you could be stuck if you want a 5-year span, by the end of the year 3, it could be obsolete compared to what's available out there now. So here's an example of when you launch a machine. So you can launch a single Windows machine. There's a setting for specifically for high memory applications like HFSS, and the image is an image that we've developed. So this is 22R2 with the latest update, and then you can see there's recommended instance type. So you have this one. These are high memory instances. So you can see there, this is 4,000 gig of RAM, so it's quite a bit. And it goes up to 60. This one goes up to 64 cores. So what we can also do is build you can build a cluster as well with more than one with the portal. So you could cluster 4 or 5 of these together if you wanted to. Yeah. So we also provide physical hardware. So we can provide a service where we can spec out a machine for you. We can provide that machine and have that machine or machines installed and configured optimally for you as well. So feel free to contact us about that. And we can also help you to get the most from your existing hardware and software. So it could be you already have machines, but they're not optimally configured, or they're not connected together with the InfiniBand or whatever it is. We can help out with that as well. So now I'm just going to we're just going to go to a Q&A session. So basically, there's on your GoToWebinar panel, there's a chat section. So feel free to just drop some chats in questions in the chat, and we can do our best to answer them.
Again, I want to stress that we're always there for you. So we appreciate some information can be overwhelming, but we're always there for you. So our motto is really simulation is more than software. So we will be there to configure your hardware, software, to get the most out of your investment and have the best HFSS experience out there.
How long a sort of investment in a workstation? How long would you see that life be for that machine? Would it depend on the number of cores, or?
Well, I think in general, Alex would be able to answer more specifically about HFSS, but in general, people see about 5 years as a reasonable investment time for a workstation. I think that's probably.
Well, the issue is people always expect more and more complicated models. So if I can't imagine people over 5 years simulating the same models, because their customers will ask for more accuracy, they will have more like more fancy ideas. They want to have newer products, faster products. So if you're doing the same thing, you can stay with the same workstation forever. But if you always want to have more accurate and faster, which is I hear all the time, more accurate and faster, then I think 5 years for a workstation is a good rule of thumb.
Yeah.
Yeah, I think I'd add to that as well. I think what we see in practice as well, a lot of people will use the workstation until it literally falls apart. So it's
Yeah.
People say 5 years, but that's kind of just an accounting term, really.
Yeah, which is fair enough. Yeah, I mean, I can understand these things are not the cheapest, so I can understand that. But now you have alternative nowadays. I mean, you're spoiled with choice. You can use cloud. So for any like spike in demand, you can just use cloud very quickly, and it wraps up. I mean, very quickly. So for situations where you have like a spike in a project load or in the requirements.
Yeah. Well, I can't see any questions.
Yeah, I can't stress enough. Turn hyperthreading off, please. Yeah, turn hyperthreading off. It's a setting in the BIOS, so it's different to every computer. I appreciate it's not very obvious. I mean, but I assume most of you know what a BIOS is and how to get there. And if you don't know, then ask your IT or ask Bob. It makes a huge difference in HFSS performance.
Yeah, it's generally just finding out the make and model of your computer and just Googling it and looking up if it's HP or Dell, then it'll be on their website really, which setting it is in the BIOS. So it's, yeah, but again, just contact us and let us know if you can't work out how to do it.
Exactly. And if you're doing if you simulating big structures and you're using SPR solver, then you need a GPU. That's also actually one of the takeaway messages here. Is GPU for SPR solver. It makes a huge difference.
Great. Well, thank you. That was a great webinar, guys. Thank you very much. There are the handouts that you can download from the handout section of the GoToWebinar control panel, and you'll receive in a few hours a link where you can rewatch this webinar and share it with your colleagues as well. So that will be online in a few hours. Well, again, thank you for attending today, and have a good day. Thank you.
Thanks everybody.
Thanks everybody.
Yeah, thanks everyone. And thanks Alex and Bob. A lot of hard work in that. Well done. Thank you.